And so what do we really mean by the subtraction abbreviation? Well, in algebra, or even with numbers, when we put terms together, we are always using the operations of addition and multiplication. Now, the reason for this is really that addition and multiplication have two really nice properties to them. And those two nice properties are the commutative property and the associative property. The commutative property is really just saying that if I've got a plus b, and then that's going to be equal to b plus a. It doesn't really matter which order that I add them together, it will always give me the same answer. Multiplication does the same thing. A times b is going to be b times a. 2 times 3 is the same thing as 3 times 2. 2 plus 3 is the same thing as 3 plus 2. So the order doesn't really matter. The second property that's really nice and we kind of take for granted is the associative property. Now the associative property is there to tell us that when we're adding multiple times, again, order doesn't matter in how we do it. We can either add the first two numbers and then add the third, or we can add the second and third numbers and then add the first. The associative property is there to tell us that it doesn't really matter which order that we do those in, we're still going to get the same answer. The same thing holds for multiplication. If we have a times b times c, we can do a times b and then we can multiply c, or we can do b times c and then multiply by a, and that's still going to give us the same answer. So 2 times 3 times 4 is going to be the same thing as 3 times 4 times 2. And so the order doesn't matter with that. Those are two really, really nice properties to have. And that's why we always think of, so addition and multiplication do possess those properties. Now, with subtraction and division, that is not necessarily the case. They do not possess these properties. And so kind of just looking at some examples from that, if we have 5 minus 3, that's going to give us 2, but if we just switch the order of that and do 3 minus 5, now we get negative 2. So 5 minus 3 is not 3 minus 5. Order matters, we get a different answer. So we do not have the commutative property of subtraction. And likewise, we do not have the associative property of subtraction either. If we do 5 minus 3 minus 1, and we do the 5 minus 3 first, that's going to give us 2, and then minus 1 is going to give us 1. But if we rearrange those parentheses and do 5 minus, and we do the 3 minus 1 first, well, 3 minus 1 is going to give us 2. 5 minus 2 is going to give us 3. And so, again, we get different answers depending on whether we group the last two terms or the first two terms. And so we have no associative property of subtraction either. Same thing is going to hold for division. We don't have a commutative property for division. We don't have an associative property for division either. And so subtraction and division are kind of strange and different operations in that they don't follow those nice rules that we like to have. And so how we really think of numbers is that we have numbers and we have the opposite of numbers. And the opposites of the numbers are really called additive inverses. Now, what those things are, they're just the numbers that are on the left side of 0. And so we can think of our real number line as being set up at 0 being kind of the center value, and then we've got all of our counting numbers 1, 2, 3, 4 off to the right, but then we've got the mirror image of those off to the left. So -1, -2, -3, -4, those are going to be the opposites because they are the opposite side of the number line. They're the reflection across 0. So the reflection of 1 across 0 gives us -1. The reflection of -2 across 0 gives us 2. The reflection of 3 across 0 gives us -3. And so we have something that's very symmetric that we set those up as the numbers and their opposites. And so whenever it comes to adding and subtracting an opposite, we think of it as doing this. So we see the number 5, and then the addition sign, we're really thinking of that as telling us to face to the right. Now, how do we add on the opposite of a number? Well, we take that -2 and we see that as telling us to turn around from the direction that we are facing. So if we're facing to the right, we turn around, we take 2 steps, and that's really going to take us back to the left. And so if we say we face to the right and turn around, that is pretty much exactly the same as just saying, oh, just face to the left. So if we have something like 5 plus a -2, well, our instructions would say face to the right, addition would say face to the right, and then we see the negative on the 2, which tells us to turn around. So face to the right, turn around is exactly the same thing as saying just face to the left. And so 5 plus a -2 gives us the same answer as if we did 5, face to the left, take 2 steps, and so we get an answer of 3 in both cases. And the same thing works if we have subtraction. So let's suppose that we have 5 minus the -2. Well, how does that work? Well, we see the subtraction and tells us to face to the left, and then the negative tells us to turn around, to change the orientation from whichever direction we're standing. So face to the left and turn around is exactly the same thing as face to the right. And so 5 minus the -2 is really 5 plus 2. And so we can ask ourselves, well, does this really mean that we shouldn't write subtraction when we're doing things? And the answer to that would be no, absolutely not. We should use subtraction, and we can use subtraction. But we just have to realize exactly how we are using it in terms of our algebraic manipulation. And so we're really going to think of that subtraction as adding on the opposite, or adding on the negative of a number. And that way we're using our operation of addition, and we're using the nice properties that it has, that we use our nice properties of addition. And so it kind of gives us a way out to use our nice properties, but still using the subtraction. And so what this really kind of leads to is us really more thinking of subtraction as an abbreviation for adding on a negative. And so when we talk about the subtraction abbreviation, that's really what we're talking about. I mean, it would be similar if we were writing sentences that said, I cannot go to the park, but instead we wanted to shorten that and use an abbreviation, I can't go to the park. And so I can abbreviate my cannot with can't, and as I'm reading this, I'm really recognizing that, oh, can't is an abbreviation for cannot, just like 5 minus 2 isn't really an abbreviation for 5 plus the -2. So it gives me a way of being able to take advantage of the nice properties that only addition has, but still to use this operation of subtraction as we are just kind of doing as the opposite of addition, if we want to think about it in those terms. So that's really how we're thinking about these things, as we will be moving terms around and shifting things around later on when we're doing our algebraic manipulations. And so seeing these abbreviations, it's important to recognize when we see kind of our algebraic manipulations. So whenever we see somebody do something like this, they start with 2x minus 3, and the next step, this becomes -3 plus 2x. We really need to recognize what was really going on there. And when students see this, some questions that they may come up with, if they're not really seeing things correctly, are things like, well, why did the subtraction sign suddenly go with the negative, go with the 3? Why did this thing go with 3? And another common question is that exactly why did that plus sign appear in front of the 2x? In my expression on the left, I had no addition sign, and so that addition sign just kind of shows up whenever I move this out of the way. Well, what happens? How does that actually appear? And so we get kind of weird misconceptions kind of going on in the student's mind when they're seeing these manipulations, and they may end up thinking of something like this, that all of these things end up getting treated like a multiplication, where they just, in their mind, they're grouping the 2x, the plus sign just appears, and this is something like multiplication, and they switch these around, and then all of a sudden we drop the parentheses, and this is some kind of multiplication thing that was happening here. And so when we put in and evaluate a number for x and try to evaluate, we get all kinds of strange, weird answers, because in their mind they weren't really translating these things correctly. And so it's really kind of important to recognize, or to know, that you are reading your expressions correctly, and that you're recognizing the abbreviations for what they are, and really why we are actually doing the abbreviations. And so to kind of take you through the steps that are really happening there, is that we have the 2x minus 3. We're recognizing that as an abbreviation for 2x plus a negative 3. So that's our subtraction abbreviation. And then what happens there, now we're using the commutative property of addition. So the commutative property of addition just says we just swap these two around, the addition sign. So we get a negative 3 plus the 2x. And so the real answer that we have is a negative 2, or negative 3 plus the 2x. This isn't the operation of subtraction. It's really the number negative 3 that's there, and the addition doesn't just appear. It was actually there all along, and it was contained in the abbreviation. And so part of this is really just learning to recognize and learn the language of the expressions and why we're actually doing what we're doing.